Assalamu alaikum and good morning, afternoon, or evening, depending on when you are going to be watching my presentation. I am Muhammad Nabil Arbi bin Mahmoud Rizal Arbi, carrying the matrix number of 82745. And today I will be presenting about my final year project one, which is titled Automated Class Attendance Using Facial Recognition. Throughout this project, my supervisor is Dr. Muhammad bin Hossein. So, without further ado, let's get into the introduction. So first of all, we need to clarify the importance of an attendance management system. So throughout the course of history, we can see there are many methods that people try to do to combat something like proxy attendance or just absent employees in their workplace because employee absenteeism actually affects the company's productivity and overall profit. So this is something that companies like to try to combat because they would like to get as much profits as they can from their workers, right? So with this, they made attendance management systems. The most common being the most common form of attendance management system is actually the manual attendance. Something that we probably all of us have already went through is like the normal roll call system or something that you write your name on a piece of paper and that's already the proof in a way of you being present in that sort of activity or class or day depending on what institute or what organization you are working or learning in. And currently, even the modern techniques, we still have some kind of involvement of like manual attendance. Some universities even still use manual roll calls and a lot of high schools still do it. It's still if you do a roll call, it's foolproof because almost foolproof because you require the person to actually um, answer you for you to confirm that they are present that day. But at the same time, it is very inefficient because you need to spend like 5 to 10 minutes every time, and classes are only like for only like 60 minutes at least. Usually, it depends, but still, it takes time nonetheless. Another modern technique is like RFID cards. This is very efficient. This is used in a lot of like organizations and companies. But the problem with this one is that people can do body punching. So what body punching is, they just take someone else's RFID card and they scan it for them that day. So let's say you want to cover someone else's shift, they just take that card, they go to work and falsely scan even though that person is not present. And lastly, there's also the QR code, which is very common in universities now. There's a lot of universities that I know that uses QR codes. Actually, not much, not many, but there's a lot that exists. And this is very efficient. This can be done very fast. But there's some problems. One is like hardware problems. Not all students can scan. Let's say their camera is broken, so you would still need manual attendance for those specific students. And QR codes, the glaring issue with it is that someone can just snap a picture of the QR code and send it to those who are at home, just chilling at home, and they can just scan the attendance and they're basically at class anymore already. You know what I mean? And yeah, those are just the core issues of these traditional methods and these current modern methods as well. So a lot of companies, a lot of people are investing into a shift of system. They are trying to make biometrics the most used way to record attendance because with biometrics, when you consider someone's biometrics, it's almost foolproof that that person is actually there. You want to make sure that the person is in person there at the event. So for my project, these are the problem statements. We go back to the points that I mentioned and elaborated on earlier. The proxy attendance, digital loopholes like the QR attendance earlier, um, inefficiencies because you need to take time for them to all scan the QR code or all of them to be called in the roll call. And also, let's say they are using biometric authentication systems. But even these current biometric systems have flaws. So let's say existing facial recognition applications, they need a one-to-one verification. Basically, what one-to-one means is that, let's say you have a camera in the entrance of the room, and that camera scans for the faces, for the attendance of each person. Well, it sounds good, but everyone still has to queue for the camera, right? So it's not a one-to-many relationship, it's a one-to-one relationship. Everyone needs to stop in a queue to scan their face first before entering the class or room. So that's, uh, in that sense, an inefficiency comes up, because what's the point of doing that if it's still gonna be as efficient as calling the names? So comes to my project. To solve all of this, we need to actually list down some aim and objectives. So the aim of this project is to develop a robust third-party automated attendance system. So basically, what this means is that the attendance system can be integrated into any organization, institution, as a third-party software. So it acts as a solution software, and mainly we will be using YOLO version 8. YOLO is you only look once. It's a Python library for computer vision and object recognition. And yeah, this is for multi-face detection. So remember from the one-to-one earlier, this is actually the reason. This is actually how we solve the one-to-one inefficiency. We use computer vision to do a one-to-many relationship using only one camera. And the objectives is we're gonna design a scalable framework. We're gonna develop the system using Python, integrate it using computer vision, which is, as I said earlier, the YOLO V8. And we're gonna evaluate the system's performance based on the accuracy, the speed, and the usability. For the scope of this project, again, we're gonna be using YOLO V8, and our goal is that when people enter the room, they don't actually have to look at the camera. They can just walk by and their faces will be scanned. So that's our end goal. And the target users that we'll be targeting for the end of this project is the super admins and the client admins, which are categorized into two different things. One is this for the system maintenance, like the overall admin, and the configuration. You can think of it like HR people. And client admins, managing student profiles. These are like the lecturers. Okay, so we're gonna test this. The testing boundary is around university lecture classrooms only, because we can't develop something. I can't develop something very foolproof yet, and it will be deployed as a hardware agnostic third-party solution. Now, this is the methodology I'll be using for the project. It is prototyping. Uh, some even say this type of prototyping as evolutionary prototyping, but we'll just be calling it prototyping. So first we have a design phase, and first we will be preparing, which is this phase. Then after that we'll be designing, building, reviewing, and then refining. Um, so in the preparation stage, we need to define what's the must-have features of this project. Then inside the design phase, the four that I mentioned earlier, the four phases I mentioned earlier is actually like a cycle until the end product that we want uh, is there. We'll be still using the cycle. So inside the design phase, we'll be looking at the database schema, like we'll be designing all the diagrams, use case, stuff like that. And then when we build the prototypes, we'll be that's inside the building phase. Maybe version 1 is only for detection, then version 2 is for recognition, and so on and so forth. Then after that, we'll be doing like things like reviews and evaluations. This one most probably will be using the SUS, um, system usability scale, and we can at the end refine the code and optimize it for certain hardwares. Through my literature review, I found a few other applications or third-party solutions that tackle this problem in the same way. They have biometrics and also facial recognition systems for attendance. And These solutions include like Jibble, TrueIn, and BioEnable. These three solutions still have their limitations, though. For example, for all of them all of them are one-to-one connections. Jibble, TrueIn, and BioEnable all are one-to-one. And for Jibble, it's for TrueIn and BioEnable. Sorry, TrueIn and BioEnable, they have their specific hardware that you need, like the kiosks and their proprietary firmware. Whereas for Jibble, anyone can download it on their phones, which is very useful for the employees. And the cost, let's say the cost for all of them, not all of them, Jibble and TrueIn have subscription costs, which is very which can be a liability to the company. Whereas for BioEnable, it's an upfront cost, but it's very high because you need to buy all the firmware, and the initial fee is not it's not a joke as well. And one more thing that I want to mention is that not all of them are offline capable, as in they need to be connected to the internet for it to work. For example, Jibble and TrueIn, they need to have a synchronization with the dashboard, like the admins, for it to actually work. If not, if let's say the employee came in to clock in their time, but they don't have good Wi-Fi connections, they don't have a good internet connectivity, it's gonna mess up the synchronization in the system. So you need to have constant internet for it to work properly. Whereas BioEnable, they have like their own centralized data if you buy the system, so it's capable for offline attendances, but you still, again, for BioEnable, the main issue is their cost. You need to buy the firmware, you need to buy everything, and it's still all of them is one-to-one connections, so they're all very slow. Whereas for the proposed system, it's a one-to-many detection. The hardware is using any general, not webcams per se. Webcams are good enough, but preferably maybe those security cameras are enough as well. 1080p or 720p. The cost is low because most of the softwares that the libraries are used are open source, and it's fully offline capable. It's fully offline capable. So this is a use case diagram that I have designed for this project. As you can see, um, we have three actors: the student, lecturer, and admin. Then we have 12 use cases, which I'm not gonna say all of them in detail here. But basically, what's gonna happen here is the student is a passive actor. Is he's just gonna they're just gonna walk by the camera, and as long as their face is detected, their attendance is logged. For the lecturer, they can start and stop a session, which is basically their lectures. And whenever they start, the system is gonna start monitoring the live feed. It only monitors the live feed when the lecturer starts the session. So lecturers and admins are actually active actors in the use case. And lecturers can also have they also have a feature that they can use is manual override. So let's say someone's face is not detected properly, or someone's face is detected as someone else, which is unlikely but always possible. So they can always just manually override that. Another thing is for the admins, they can also manage the students' profiles. They can configure the system settings. So let's say the lecturer forgot to manually log their attendance one day. The student can come up to the admin and ask for the manual attendance, and they as long as they have proof that they came to the class that day. So the expected outcomes for the project are just like the high efficiency that it potentially offers. So let's say everyone is able to just walk by the camera and scan their faces. It's very efficient. No more problems with the queuing problems. No more waiting for around 10 minutes for the class to start. They can just walk in, scan their attendances, and sit in class. It also offers high integrity. That's one of the expected outcomes. High integrity, basically, we managed to solve the very prominent problem of proxy attendance and body punching, which has happened so much in the past in many of the attendance systems. And it's also very cost effective. It's another problem that we want to solve. We want it to be cheap. These kind of things, these things that deal with integrity shouldn't be very cost effective. Shouldn't be very costly. Sorry, it should be cost effective. And last but not least, we need to make it scalable. So this has to be designed in a way that it's easily integrated into existing enterprise systems. So yeah, that's it for my presentation. Thank you for listening to everything. Bye bye.